मधुर मनोहर अतीव सुंदर ये सर्व विद्या की राजधानी राजधानी।
Well, my dear students, now we are going to start the second lecture on technology of metal forming. In this lecture, we will speak on the cold, warm and hot working processes in general, because now we are going to deal with the technological aspect of metal forming, and almost all metal forming processes, it is carried out under either cold condition or warm condition or hot conditions, depending on the nature of the product, depending on the shape and size of the product, and depending on the workability requirement. So, let us see what happens when we form any of the metal forming process like rolling, forging, extrusion, drying or sheet metal working under these conditions, cold, warm or hot. What happens, what advantage we gain and what disadvantage we gain, and what is the best way to get the product defect free, economical and quickly. So, that is the objective in this lecture, and we will cover all these things. So, under this lecture will, as far as the delivery is concerned, it will consist on an investigation of cold, warm and hot working processes under these following topics usually. Number 1, we will see the characteristics and description of cold, hot and warm working. We would also see the homologous temperature on which or within which these forming processes are carried out. The thirdly, the effect and the type of working, that is cold, hot or warm, has on the material, we would see, and then we will also see the main methods that is used and their characteristics for the processes. At the last, we will see the effect the type of method has on the process for the different products. So, we would cover our talk under this lecture on these 5 major issues. Now, you know that the cold working refers to plastic deformation that occurs usually but not necessarily at room temperature. For an example, at room temperature, if you form a lead material, we call it as a hot forming even at the room temperature, and that is why the cold working refers to plastic deformation that occur usually but not necessarily at room temperature. The hot working refers to plastic deformation carried out above the recrystallization temperature, and warm working, as the name implies, is carried out at intermediate temperature. It is a compromise in fact between the cold and hot working process. The temperature range for these 3 categories, that is cold, hot and warm, of plastic deformation are given in the next table, which is given in table 1. In terms of a ratio, where capital T is the working temperature and Tm, capital Tm is the melting point of the metal, both on absolute scale. Although it is a dimensionless quantity, that is capital T by capital Tm, the ratio is known as homologous temperature. This homologous temperature, which is a ratio of capital T by capital Tm, it becomes an indicator for the different hot, cold and warm working processes. So this table 1, you can look here the homologous temperature range for various processes. For an example, the cold working process, the ratio, homologous temperature ratio range is less than 0.3. If it is less than 0.3, we call it as a cold working. When it is between 0.3 to 0.5, it is called as warm working, and when it is more than 0.6, it is called as hot working. Usually metals or alloys can be plastically deformed or worked at room temperature, warm or high temperature, which is called as hot working. If you look at these three types of working which is described in this table, it will be described in detail in the next slides. So if you look at the cold working, what happens to the cold working? So cold working refers to work hardening condition. As you are aware of what is work hardening, when you deform material under plastic and yielding takes place. So a condition comes when it requires more load. You all might be aware of that. So as stated before, cold working refers to plastic deformation that occurs usually but not necessarily at room temperature, as I gave you an example of the lead. For example, deforming lead at room temperature is a hot working process because the recrystallization temperature of lead is above room temperature. The cold and hot are in fact relative terms, right? So plastic deformation is a deformation in which the material does not return to its original shape. You are all aware of this. This is the opposite of an elastic deformation, therefore. So what happens in cold working? The behavior and workability of the metals depend largely on whether deformation takes place below or above the recrystallization temperature. That is the difference. So deformation using cold working results in number 1, as you are all aware, higher stiffness and strength as compared to all the process, whether it is warm or hot. So in cold working, we have the product will have higher stiffness and high strength after cold working, and reduce malleability and ductility of the metal as well. And another thing is anisotropy. Whereas in hot working, if you see, the hot working is the deformation that is carried out above the recrystallization temperature, as you are aware. In these circumstances, annealing takes place while the metal is worked rather than being a separate process. The metal can therefore be worked without it becoming work hardened. Hot working is usually carried out with the metal at a temperature of about 0.6 of its melting point, therefore. As a result of hot working, we have that is at high temperature, what happens? The scaling and oxidation may be formed therefore scaling and oxidation exists. Scaling and oxidation in fact produces undesirable surface finish. Most ferrous metals usually needs to be cold worked after hot working in order to improve the surface finish therefore. Secondly, the amount of force needed to perform hot working is less than that of the cold work. Thirdly, the mechanical properties of the material remain unchanged during the hot working. Fourth, the metal usually experiences a decrease in yield strength when hot worked. Okay. Therefore, it is possible to hot work the metal without causing any fracture. That is a good thing. Quenching is the sudden immersion of a heated metal into cold water or oil. It is used to make the metal very hard. To reverse the effect of quenching, temperature is used, tempering in fact, tempering is used, that is it is reheated of the metal for a period of time. To reverse the process of quenching, tempering is used, which is the reheat of the metal, alright. So, whereas if you look at warm working, so as mentioned before, the warm working as the name implies is carried out at intermediate temperatures. It is a compromise between cold and hot working. We get the good thing of cold working and combined with good thing of hot working, and and therefore it is a better process. The temperature range for cold, warm and hot process was listed in fact, if you again see back the table 1. So, the range of warm working is between 0.3 to 0.5 as the homologous temperature ratio. So, that is the T by Tm. Okay. As far as the effect of warm working is concerned, the effect of this type of working depends on how close is the warm process to be a cold or hot process. This means that the effects and characteristics get similar to the one in a cold process when the warm process gets closer to 0.3. This also applies for hot processes. The effects and characteristics get similar to the ones in a hot process when the warm process gets closer to 0.5, right. So, the type of process chosen depends on the physical and mechanical properties needed for the product, meaning the product itself and its uses. So, based on these very basic the process details, let us see different methods that we are going to cover in the whole of this course, technology of metal forming. So, different methods for cold, hot and warm working. We would be covering the different metal forming processes like rolling, forging, extrusion, drying, there is drying of sheet, drying of rod, drying of tubes, and sheet metal forming. So, sheet metal forming, the cup forming, the shallow cell forming, the hydroforming and unconventional high velocity rate forming, all those things we will cover under this. So, these are the different processes we would be dealing under this course, alright. So, let us see in brief what happens in rolling process. So, under rolling process, the initial breaking down of an ingot or of a continuously cast slab is done by hot rolling, right. So, a cast structure includes in fact coarse and non-uniform grains. This structure is usually brittle and may contain porosities as well. So, hot rolling converts the cast structure to a wrought structure. This structure has finer grain and enhanced ductility, therefore, both resulting from the breaking up of brittle grain boundaries and the closing up of internal defects, especially porosity, etc. So, that is how what happens to the rolling process. The product of the first hot rolling operation is called bloom or slab. You must know this. A bloom usually has a square cross section at least 150 mm around, that is around 6 inch on the side. A slab is usually rectangular in cross section. Blooms are processed further by shape rolling into structural shapes like I section, L section, etc., such as railroad section, right. Slabs are rolled into planes and sheets as well. So, the billets are usually square with a cross sectional area smaller than blooms. They are later rolled into various shapes such as round rods and bars by the use of shaped roll that would cover in detail when we take up these processes one by one. Hot rolled round rods are used as the starting material for rod and wire drying. They are called in fact wire rods, etc., right. So, look at this video where the rolling of simple rolling process is shown. You can see rolling, the different types of rolling are, so 2 high rolling mill, 3 high rolling mill and many others. So, you can see this video where the rolling is taking place, alright. You mark the roller, type of the roller you have, the how the initial slab is taken into, it is beaten, and then it how the deformation is taking place, alright. The second, this is second video where the another version of the rolling is shown, where a very industrial issue of the rolling which is carried out locally here. Here the sheet, hot work sheet goes through the, it is a in fact 3 high rolling mill rather. So, it is a reversal kind of mill, you can see here. So, this video and there are many other. A big rolling mill involves number of series of such rolling setup to have a very large deformation. So, you may have a slab of say 8 inch, around 7 inch to 8 inch, and it may be reduced to 1 mm or less than that. So, it requires multi-stage rolling process. So, the another process is forging, very oftenly used forging process, it may be cold forging, it may be warm forging, it may be hot forging as well. So, the forging is a process in which the workpiece is shaped by compressive forces applied through various dies and tools. It is one of the oldest metal forming operations, as I explained in the very first lecture of this series as the history of the forging. It is the oldest metal forming operations. Most forgings require a set of dies and a press of a forging hammer. Unlike rolling operations, which generally produce continuous plates, sheets, strips or various structural cross sections, forging operations produce discrete parts, in fact, not continuous. Typical forged products are bolts and rivets, connecting rods, shafts for turbines, gears, hand tools and structural components for machinery. Aircraft, railroads and a variety of other transportation equipments are some of the examples of products that are produced by various forging processes. Look at these three different types of process. One which is open die forging, if you look at. So, these three stages A, B, C. So, open die forging, where the workpiece is held between these two platen die, which is called as dies, upper die, lower die, and it is being forged. You can see in the second how the forging takes place and the height reduces, and then the third stage, because there is a friction between the upper and lower die contact with the, and so you will see the barreling action taking place. So, that is the usual happens in open die forging. Another case has been shown here in cold die forging. You can see the die, the upper die, lower die and the blank, and it is being compressed under some impression. There is some impression on the top die and there is some impression in the bottom die, and that is how you close it and you get the impression transferred to the workpiece. And finally, there is some flash comes out, so that the whole volume of the impression gets filled and flash comes out. So, this is what the simple case. Generally, hot work processes are used for this. Another case has been shown, which is flashless forging. This is also called as near net shape forging. You can see there, where there is no flash formation. So, again you can see the forging, there is no flash. So, this figure, where the workpiece deformed with open die, closed die and flashless forging, shows some of the process of forging. Here you can see in the video, the video where you have the very beginning, how the forging was done, that is the blacksmith forging. Then you see the forging by a power hammer. So, you can look at the type of force, the pressure, the stroke which is being provided by the hammers, and the size of, it depends all the size of and temperature of the workpiece that you are going to work on, and accordingly you select a proper press, proper hammers, and accordingly. So, you can look into the complexity of this forging process, right. So, the another process, when we call it as a extrusion process. In the extrusion process, a billet, generally round billet, is forged through a die in a manner which is similar to squeezing toothpaste from a tube. Almost any solid or hollow cross section may be produced by extrusion, which can create essentially semi-finished parts because the die geometry remains the same throughout the operation. Extruded products have a constant cross section. This can be done with cold, warm working or hot working, depending on the type of die you are using, depending on the type of material you are using, depending on the conditions, working conditions. Typical products made by extrusions are railings for sliding doors, tubing having various cross sections, structural and architectural shapes, and doors and windows frames, etc. So, look at this figure. This figure shows a process which is a forward extrusion process, where you have a pressing stem or ram, you have a container which contains the billet, and it has a container liner, and it has a dummy block which directly bears the pressure of the pressing ram. Then you have a die, then you have a die backer to support the pressure of the die, and then your extrusion comes out. So, this is a forward. Likewise, there is a backward extrusion as well. So, you can look at this video where the forward extrusion has been shown, and you can see the extrusion can be in cold, it can be in hot. So, you can see usually in hot extrusion you have the billet to be heated in furnace, and then it is taken out, and then it is loaded on the, and then the extrusion comes out. So, this is what the video shows, and this is just to show for you people to get aware of the process. But there are many different versions of extrusion, like backward extrusion, etc. We will explain later when we take up in the usual chapters. Another very popular process, you all are aware of wire dryings and all that. So, it is a drying process. So, drying is an operation in which the cross section of solid rod, wire or tubing is reduced or changed in shape by pulling it through a die. Drawn rods are used for shafts, spindles and small pistons, and as the raw material for fasteners such as rivets, bolts, screws, etc. Right? You are all aware of. You can cold draw, you can sometimes warm draw also, you can hot draw also. So, drying also improves the strength and hardness when these properties are to be developed by cold work and not by subsequent heat treatment. So, this figure shows a usual drying process. You can see the drying die is very important, and the role of land, the role of die angle, and all these things are very important, and there is a pulling force here. In case of extrusion you have a pushing force, whereas in case of drying you have a pulling force. There may be tension, back tension as well. So, you can draw the solid rods, you can draw wires of different size. This is what is shown in single stage. There may be a multi-stage drying as well, like this video shows. a multi-stage drying operation, where if the drying is large, so initial wire can be reduced one by one, passing through number of these stages of the wire from through different reductions, and then you get the final wire, which is quite, because usually there is a limitation in reduction. So this video shows such kind of multi stage wire drying process. Another very interesting process is sheet forming. The examples of products which are made by sheet metal formings are decks, file cabinets, appliances, car bodies, aircraft fuselages, beverage cans, etc. Many more. For aerospace applications, the common sheet materials are aluminum and titanium, and they are usually cold worked, but sheet forming in general can be done by hot or cold working processes. There are many processes used for sheet metal forming. The main processes are like you have roll forming. Say in case of roll forming, the process is used for forming continuous lengths of sheet metal and for large production runs. The metal strip is bent in stages by passing through a series of rolls. The parts are then usually sheared and stacked continuously, whereas if you see the stretch forming process, the sheet is clamped along its edge and then stretched over a die or forming block, which moves upward, downward or sideways depending on the particular machine. Stretch forming is used primarily to make aircraft wing skin panels, automobile door panels and window frames, etc. Okay. Usual drying process, you can draw wires as well, as I said. A round sheet metal blank, in case of drying, a round sheet metal blank is placed over a circular die opening and is held in a place with a blank holder. The punch travels downward and forces the blank into die cavity and thus forming a cup. So variety of cups, bowls you get of different materials, stainless steel bowls, cups, etc. very popular. So this is what the sheet forming process. Look at this video. This video shows such kind of one of the short video to show you the details of cup forming process. This cup may be a round one, it may be a rectangular one, and it may be of different triangular shape as well. So this one gives you a feel of how the process takes place. Here you will see the die design part for the sheet forming, cup forming is very important. The punch diameter, the clearance, the cup initial blank diameter, the speed, ram speed, this is all part of process design issues, right. So we have covered in general that the different topic we would be covering here, including cold, warm and hot process. So in as a conclusion, I would repeat that the term cold, warm and hot working are in fact relative sense. The difference between them is the temperature at which the process is carried out. Secondly, there is not a best process, right? There is no such best process. It all depends on what will be the use of the product, or what is the product going to do with, or what is going the product is for. The geometry of the product has a great influence therefore on this decision itself, right. So, in the subsequent lecture now onward, we would go into details of all these processes like forging, rolling, extrusion, drying, sheet forming. We would see in detail, including the technological aspect of metal forming. So, these are some of the references that you can refer, especially for this particular lecture. The Kalpak gem and Smith book, this is Prentice Hall publication. J.N. Harris book, it's volume 36, and you can refer ASM handbook, a source book also, and there are some of the websites that you can get more details on this. So, hopefully you might have understood the basic of, and because this process, this lecture is very important in the sense, the now onwards the individual topic that we would be covering, it would all derive from this basic. So, I thank you all for keeping patience and hearing carefully, and hopefully you will give me your feedback, because this is a web based lecture for helping you people. So, your feedback is necessary. You can give your feedback so that we can improve upon. Thank you once again. Thank you very much.